5.7 Systems of Linear Inequalities. So first, we're going to talk about testing an ordered pair to see if it's a solution. So on this example, I'm going to test if negative 1, 5 is a solution to the system of inequalities. So I've got more than one inequality here. Okay. So what I want to do is substitute that xy pair into both inequalities and see if it satisfies it or not. So see if it's true or not. So if the statement is true, the ordered pair is a solution. If the statement is false, then the ordered pair is not a solution. Okay. All right, so let's test it out here. I'm going to plug in 5 for y into this, and I get 5 is less than 5. Well, that's false, right? I got a false statement there. 5 is not less than 5. And I'll just plug it into the other one just while I'm at it. So I'm plugging in 5 for y and negative 1 for x. And then I get 5 is greater than negative 5. Well, this one is true. But if the ordered pair doesn't work for either of the, it doesn't have to not work for both of them. If you get one false statement in there, then I know my answer is going to be no. That ordered pair is not a solution to the system. Yes, it's a solution to this inequality, but it has to be a solution to both of them to be considered a solution to the entire system. Okay. All right. So let's try another here. Let's plug in this xy pair. I'm going to plug in 4 for y, and I'm going to plug in 1 for x. And it's a good idea to use parentheses whenever you substitute. So then I've got 3 plus 1 over there, which would be 4. This is true. 4, when it says 4 is greater or equal to 4, well, 4 is equal to 4, so that works for that one. Okay, so then plug in 4 and 1 here, and I got 4 is greater than 0. That's another true statement. So since it works in both inequalities, then I can say that yes, the 0.14 is a solution to that system. It's not the only solution, but it is a solution. Okay. All right, so we're going to look at graphing systems of linear inequalities. So this is very similar to graphing just a single linear inequality, except we're going to have more than one of them on the same xy axis. Okay, so it says graph both inequalities on the same page using these steps, and this is just the steps for graphing any linear inequality. So we're going to graph the boundary line using the related equation. We're going to use a dashed line if we've got one of these symbols, so where the inequality symbol is not underlined. When it is underlined, then we're going to use a solid line. Okay, and we're going to have to shade one side or the other of each of those boundary lines, and so we're going to figure that out by using a test point. Usually I use the point 0, 0, but if 0, 0 is on the line, then you'd want to pick another point. Okay, and we're going to shade the side that works. So I'll show you in an example in a minute. Okay, so the solution of an inequality is the region that is double shaded. That's assuming that we've got two linear inequalities. If you had 3 linear inequalities, then it would be the region that's triple shaded, or if you had 4, the part that's quadruple shaded. So it's the part that's shaded the most is going to be where the solution to the whole system is. And it is possible that there is no solution, because you could get something like this, where let's say these are my 2 boundary lines. I made one of them dashed and one solid just for fun. But let's say I picked a test point and it worked up there for this inequality, but then when I was doing this one, it worked down here for this one, and there's no double shaded region, so this would have no solution. That can happen. Usually the shaded parts will overlap, and then we will get a solution. Okay. All right, so let's try a couple of these out on the next page. Okay, here I've got this system of inequalities. I'm going to graph both of these inequalities on the same graph, so I'll color code these. So I'll do this one in blue pen. This one's already in y equals mx plus b form. That's pretty handy because I can see that the slope is going to be 2, or you could think of that as 2 over 1 if you're thinking rise over run. And then my y-intercept is negative 3. Okay. Also, I want to think about, is this going to be solid or dashed? And since that isn't underlined, the inequality symbol, that means I've got to use a dashed line for this one. Okay, so I'm going to start at, with the y-intercept at -3. There it is. And then from there, I'm going to go up 2 to the right 1, up 2 to the right 1, and I'll keep going up 2 to the right 1. I like to just plot as many points as I can on the line. And I'll also go down 2 to the left 1 because this is equivalent to -2 over -1. So down 2 to the left 1. Okay. And then I'm going to be careful to use a dashed line here. Okay. There's my dashed line. Okay. So I'm going to want to shade one side or the other of this line. So let's use a test point. I'm going to use 0, 0 as my test point here. So I'm going to test 0, 0 to see if this works with this inequality. So I'm thinking, okay, if I have, there's my inequality, I'll plug in 0 for both x and y and see if I get a true or a false statement. So 2 times 0 is 0, so 0 minus 3 is -3. Here I get 0 is greater than -3. Well, that's a true statement. Okay, so for this line, that means that came out true. That means the other side is the false side, and I want to shade the true side. Okay, if you're using pencil for this, shade lightly because it'll get confusing if you shade it really darkly. All right. And then let's do the same kind of thing with our other inequality. So I'll do this down here. So I can see, first off, this is going to be a solid line because this is underlined. So I've got to be careful to draw it in solid. All right. The most common mistakes I see on these are people just forget to do the dashed lines. They do all the lines solid. But yeah, make sure you are looking at the symbols there. So my slope is 1/2. And then my y-intercept is 1. Okay, so there's my y-intercept, and I'll go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, all the way across, or I could go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay, and then I'm going to draw in my solid line. Okay, and then I want to, again, try a test point. So I'm going to use 0, 0 again as my test point here. So I'm going to test 0, 0, see if it comes out true or false. So in this inequality, I'm plugging in 0 for y, and I'm plugging in 0 for x. I didn't rewrite the inequality, but I'm just using that there. Okay, so then when you simplify this, you get 0 is greater or equal to 1. Well, that is a false statement, right? This is a false statement. So that means for the red line, this is on the false side, and I want to shade the true side. So my true side for the red one would be this side of the solid line, okay? So I'm going to be shading this part as well, okay? So now it looks like kind of a mess, but the part that is the actual solution to the system is the double shaded part. So that would be in this case, it's above the red line and it's above the blue line as well. So it's this area. So I like to kind of just emphasize what the actual solution is. These single shaded parts are, any point in these regions would satisfy one of the inequalities but not the other one. And any point down here would satisfy neither inequality. But my double shaded part can pick any ordered pair there. It will satisfy both of them. So you could test it out. You could pick the point, let's say -1, 3. It should satisfy both of those. Okay. All right. Let's try another one out. So these ones, I got a little more work to do on these because they're not in y equals mx plus b form. I think that's the easiest way to graph these. So the first thing I'm going to do with these is get them in y equals mx plus b form. Okay, so I want to move the x over the other side here. And I could write -6 plus x, but I want to put the x in front of the -6, so it's closer to y equals mx plus b. And then I want to isolate the y, so I'm going to divide everything, the entire equation, by 3. Okay. And you could just write x over 3, but I'm thinking I want to write it as 1/3 times x, because then it's written as a slope, right? Because you could think of that as 1x over 3, so 1/3 times x. And then -6 divided by 3 is -2. And now I've got it in a good place. So first off, I can see that this is going to be a dashed line. Okay. And then I've got my slope at 1/3 and my y-intercept at -2. Okay. All right, so let's go ahead and graph that. -2 is the y-intercept, and then I'm going to go up 1 to the right 3, up 1 to the right 3, or I could go down 1 to the left 3, down 1 to the left 3, down 1 to the left 3. Okay, so this is a dashed line, so I'm careful here. Okay, and now I want to shade one side of this line. You can definitely do a test point like I did on the last problem, but if you've got an equation that's in y equals form, where in other words the y is on the left side of the inequality, you can use a little shortcut. So since this says y is less than, when I have a less than or equal to, then I can shade below. I can just shade below the given line. Okay, so that means this is going to be the true side for this blue line. And you can test it out. If you test it out 0, 0, you should get it should be false. So that means you'd shade the true side. Okay. All right, just a little shortcut there. All right, and then let's do the same kind of thing here. I'm going to put it in y equals mx plus b form. So I'll subtract x from both sides. That gives me 2y. I'm going to put the negative x in front of the positive 2, and then I'll divide everything by 2. So I could think of this as negative 1x over 2, so negative 1/2 times x. And then 2 divided by 2 is 1. Okay, so this one is going to be a solid line. This says greater than, so I'm going to shade above this line. It says greater or equal to, but this one I'm going to be shading above this line. Okay, and then I can see my slope is negative 1/2. You could think of it in either of these ways for rise over run. And then my y-intercept is 1. Okay, so I got a y-intercept here at 1. And then I'm going to go down 1 to the right 2, down 1 to the right 2, all the way down, or I could go up 1 to the left 2 for each, all the way across. Okay, and this is a solid line. And I'm going to be shading above this line, so I'm shading this way. Okay, and then I want to emphasize the double shaded part is my actual solution, so that's this little area here. Okay, so any point in that double shaded part should satisfy both inequalities. On the next page, we're going to be doing this backwards. So this time we've got a graph and we're going to write the system of inequalities from this. Okay. So let's start. I'm going to start with this dashed line here. The easiest way I think to do this is to think about y equals mx plus b form. So that means I would need the y-intercept. So my y-intercept here is going to be -2. Okay, and then my slope, I'm just looking, okay, from this point, how could I get to another point that's on the grid? So I'm looking, I could use this point, but you'd have to use a fraction or a decimal, and you'd have to eyeball it. So I like to look for a point that looks like it's exactly on the grid, like this one. So now I can see, okay, I'm going up 1 to the right 3. Or you could go down 1 to the left 3 would work as well. But it appears that my rise would be 1 and my run would be 3. So that would be 1/3. Okay? So now I've got y equals 1/3 x minus 2 when I plug in the slope and the y-intercept. Now this is an equation, not an inequality, right? So now I have to also put in the inequality symbol. So for this line, I'm talking about this line, I'm shading below. Okay, so that tells me that I'm going to use a less than symbol. Now I'm deciding that it's just less than, like this. It's not less than or equal to, and that's because this is a dashed line. So since it's dashed, it's just less than. It's not less than or equal to. Okay, so now I've got one of my two equations, or inequalities, I should say. Okay, so now let's repeat the process. So I'm looking at this one now, y equals mx plus b, I'm thinking, well, let's see, the y-intercept is 1, and then I'm looking for another point, and I'm going to have to go away. So it looks like that one's right on the grid, right? So I can think, okay, I'm going down 3 to the right, 1, 2, 3, 4. Down 3 to the right, 4. So that means my slope would be negative 3 over 4. Okay, so I've got y-intercept at 1 and a slope of negative 3 over 4. You can put the negative in the middle or on the bottom, it doesn't matter. Okay, but now I can plug everything in. So this one is, I'm shading, let me separate this out a little. This one we're shading above this line, right? If you look at that, that one's shaded above. So that tells me I've got a greater than symbol, okay? Sorry, let me plug in the slope and the, there's what the line would look like, but now I got to change it to an inequality symbol, right? So I'm shading above, but it can be equal to it because it's a solid line, right? So any point on this line itself would be part of the solution to this inequality, as opposed to the dashed one. The points on the borderline are not part of it. Okay, and then, oh, I forgot to put in the b here was 1 plus 1. Okay, so then there's my system. I've got my two inequalities there and there. Okay, all right, let's try it again on the next problem. So let's start with the solid line here. So here, I'll do this down at the bottom here. This has a y-intercept of positive 2 and then a slope of 1, or you could think of this as 1 over 1, right? So my slope would be 1 then. Okay, so if I was just writing an equation, I'd have y equals 1x plus 2, or just y equals x plus 2. And now let's put in the inequality symbol. So I'm just looking at this line. I'm kind of trying to ignore the dashed line, and I'm thinking, am I shading above or below? And it looks like it's shaded above, above this line. So that means, and it's a solid line, so I'm going to use y is greater or equal to x plus 2. Okay, so there's one of my inequalities. Now let's look at this one. Okay, so these horizontal lines are a little trickier because the slope is a little bit harder to tell. The slope of this is actually going to be 0. But the way I like to think about this, I know those horizontal and vertical lines are either x equals or y equals equations. So this one is going to be y equals. Okay, that if I was just writing an equation for the line, this would be y equals 4. Because every point on this line has a y coordinate of 4, right? If we look at the coordinates here, this is negative 4, 4, and this would be negative 1, 4, and wherever you go on that line, the y coordinate is 4. The x's change, but the y's are always 4. So if you put x equals 4, that would be a line like this. That's not what we have here, okay? All right, and then this is, looks like we're shading below this line here. So I'm going to say less than, and then I got to decide it can't be equal to because it's a dashed line. So just y is less than 4. Okay, and there's my two inequalities. So there's my system. Let's try a word problem on the last page here. Okay. All right, so on Saturday you have a total of 8 hours to spend at the fair playing soccer. You want to spend at least 3 hours or at the fair and playing soccer, I should say. So we got those two activities, okay? So you want to spend at least 3 hours at the fair and more than 2 hours playing soccer. So we're going to write and graph a system of inequalities to show the different combinations of time we could spend doing the different activities, okay? So I'm going to start with you have a total of 8 hours. We can actually write an inequality just from that. So if x is the hours at the fair, y is the hours playing soccer, well, when I add those together, since we've got a total of 8 hours to work with, it could be equal to 8. We could use up all 8 hours, but we could also use less than 8 hours doing those activities, right? We don't have to use up the whole 8 hours. So I've got an inequality just from that, okay? So let's go ahead and graph this one right now. I'll get to, there's other inequalities. But I'm going to put this in y equals mx plus b form, in slope-intercept form, by subtracting x from both sides. I'm going to put the negative x in front of the 8, like so. And now looking at this, I can see, okay, I'm going to have a solid line. Okay. I'm going to shade below, because it says y is less than or equal to. Okay, and then I've got a slope of -1. You could think of that as -1 over 1 or 1 over -1. And then my y-intercept is 8. Okay, so let's see, y-intercept is 8. There we go. And I'm going to go down 1 to the right 1 from there. Okay, so, and then I'm thinking this is a solid line, and I'm going to be shading below it. Okay, now I'm not going to continue my line because you can't spend a negative amount of hours at the fair or a negative amount of hours playing soccer. So we're only, this is really a line segment because it stops at these x and y axes. Okay, but I'm shading below this. So no, all of my combinations of time are going to be, that I could use, are in this region. Okay, but I want to take some other factors into account. It says here you want to spend at least 3 hours at the fair. Okay, so let's say this was our inequality for the total. Now let's write an inequality that has to do with the amount of hours at the fair. If our fair hours are the x, so we want to spend at least 3 hours, so it could be 3 hours or more, right? So that is our inequality for the fair, okay? Now, remember from the last page when we had a y equals line, it was horizontal. Well, an x equals line is going to be vertical, okay? So I'm going to draw a solid line here because it is underlined at 3. And if you think about these points, any point on this line I'm drawing right now, whoops, I shouldn't go down to the pass into the negatives. But any point on this line has an x coordinate of 3. So this would be the line x equals 3, right? It's solid. Now I need to shade one side or the other, and I can't use the above or below thing because there is no above or below for a vertical line. There's only to the left and to the right. So I'm just going to think, well, I need x values that are greater or equal to 3. So the ones that are greater or equal to 3 would be to the right of this, right? So that means I'm going to shade this way. Okay, so far, this area right here, this triangle, is the double shaded part, but I still have one more piece of information because I'm going to use more than 2 hours playing soccer. So I'm going to write a third inequality to represent that piece of info. So we want to spend more than 2 hours playing soccer. So soccer is y. So it says not 2 hours, we want more than 2 hours, so y has to be greater than 2, okay? So then this is going to be a dashed line, okay? And y equals 2 would be a line like this, so I'm going to do one like this that's dashed, and I'm not going to go into the negatives here. So I'll try to make this dark enough so that you can see it. Okay, so they've got a line like this. And this time, since it says greater than, we're going to shade above. And it does make sense above or below when you have a horizontal line. So shading above this one, and you can see how if you shaded really dark as you went, it looked like kind of a mess. It looked like the entire graph would actually be just shaded in. But I'm looking for the part that's triple shaded, since there's 3 inequalities, and that would be this area. So I want to emphasize this now. Okay, so if you think about these different places, well, that means like this point here, we could spend 3 hours at the fair and 3 hours playing soccer, and then that would work with all of these. Or we could spend 4 hours at the fair and 3 hours playing soccer, and so forth. So any point in this region, now keep in mind if it's a point that's touching the dashed line, you can't use those, but you can use ones that are on the solid line. Okay, all right. And there is the end of the section, and I'll see you next time.